Today we are going to solve lead code question number 105, construct binary tree from preorder and in-order traversal. So what the question is saying is, basically we have two arrays, preorder and in-order traversal, which are representing the preorder traversal of this tree and in-order traversal of this tree. By using those two arrays, we need to form this tree in reality. Okay, that's what the question is all about, and constraints are given here. You can go through it, and like all the values are unique in order and also appears in pre-order, and guaranteed traversal of the tree, and in order is the guaranteed traversal, like they are real, they are not any kind of bullshit. That's what they are mentioning here. So let's go to the question very quickly. So this question is not a medium level question in my opinion. It can be a hard level question also, because it is quite confusing. So we are not going to like solve together as we do in my all previous videos, because I tried doing it and it got like 40 minutes long video. So I already wrote the explanation and solution. I will explain it thoroughly to you. Okay, so let's start. So why we need to focus on pre-order and in-order first thing? Let me just shut the window, and yeah. So see, this is our pre-order traversal and this is our in-order traversal. Okay. From the pre-order traversal, we can see that we are getting the root of the tree in the first occurrence. How? See, 3 was the first thing, like 3 was the root of the whole tree. Hence, we got this in the first occurrence also, because pre-order is all about root, left, right, root, left, right. That's what we are doing in pre-order. Hence, we got the root of the tree in the first step. So we can get the root of the tree and subtree also. For that, 9 is the first thing, see, 20 is the first thing, subroot. So in level wise, we will get the roots of the tree in pre-order traversal. From the in-order traversal, what we can get is, see, if you see in-order array, this is the in-order array. So you have 9, 3, 15, 27. Okay. You can see 3 is the root, 3 is the root, and how many elements we have in the left side of the root and in the right side of the root. This is telling us that on the left subtree we have one element, which is 9, so left subtree one element, and on the right subtree we have three elements here. So whatever will be the root, right side will be the right subtree, left side will be the left subtree. That's what in order is all about. So we can find out how many elements are in the left and right side of the tree of from the root. Okay, this is the main thing of this whole question. That's why the pre-order in order will help us to form this tree. Now let's go quickly ahead. So here I am creating a hash map. Why? So what I will do in this hash map na is basically I will just use this array, this in order array which question gave me, this in order array, and I will store all this value with their indices. So see, 9 will have index 1, 3 will have index 2, sorry, 9 will have index 0, this will have 1, this will 2, 3, 4. Like that we will store it. That's why we have this. So here I am running a for loop to store all the indexes in my this hash map. Okay, why I did this, the main question is, okay, so if I have index of 3, what will be the index of 3? 1. In an array, how many indexes will be before 1? Only one index, which is 0, zeroth index. Hence I know there are one, and there will be one element before my current index. Okay, similarly, 3 is here. How many index will be ahead of this, ahead of after one index? That I will know by having right indexes. That's why I am storing this index directly in my hash map with the particular value, so that I can know which value was on which index. I don't have to traverse again and again to count how many elements are there before that particular index. Okay, that's why we created this thing. That's all, and we kept it global so that we can use it in our helper function. Now let's quickly go in this part. This is our helper function. Now what is this split helper? So you can see we have 3, we have 9, 20, 15, 7. And in order array, if we see that once we have root, we can split the array in two halves. left subtree half and right subtree half. Okay, so 9 is on the left subtree half, so this will be our left subtree half array, and this will become our right subtree half array. That's why we are using that split helper function. Here I have mentioned it very quickly. We are sending preorder as the parameter. It will constantly we will send preorder as our parameter so that we can get the root index every time. So once we have root index for this, then on the left split we will have root index 20. Similarly we have root index 9, 15, 7 and so on. And here root index, this will represent the roots index in the preorder array. So in the preorder array you can see we have 3. This will represent, this root index will represent the index of this 3 in this preorder array. It means 0. For 9 it will be 1, like that. Okay, then as I told, we have to split the array in two halves. We have to split this in order array in two halves. To split an array in two halves, we need to give two pointer, which is start and end pointer. Hence we have start and end pointer. Represent the start point for the split array and represent the end point of the split array, overall giving us the splitter left and right arrays. Okay, now let's see how this function is working basically. So here, as I defined you previously, we have a preorder, we have the index of the root, we have start and we have end. Okay, now I am creating a tree node, new node, root s, so that I can store the value of the root. So in our first iteration, parallelly, while understanding this, we will parallelly do dry run also. So here I wrote the full dry run. Okay, so you can see in our pre-order, like in our helper splitter, what will be the first thing which we will trigger? The first function which will be going to get triggered is pre-order. Pre-order root index will be 0, start will be 0, start will be 0, end will be your length minus 1, or you can say 4. We know the length of the array, and we have yeah, that's all. So these are the three things which we will have as a parameter for the first split helper, correct? This will be the, so pre-order is constant everywhere. The only thing which is changing is start, end and root index. So that's what I wrote here, root, start, end. Okay, let's go ahead here. So here I got my root. The first root is 3. So obviously my tree will start from 3. Pre-order array will give us the main first root in the first position itself of the array. Okay, so we will start. So I created a node with value 3 here. Okay, so first node will be 3. Now what will happen in our mid element? What we will store, as I told, through this Inorder array I can get the index of this 3 quickly, because we created a hash map, we created a map. So here in this mid, what we will get, we will ask for the position, or you can say index or value, which is related to the key 3. Okay, so here we sent 3, sorry, here it will be 3. So preorder dot root, we got the value 3. And what's the index of this? So first index will be 1. See, from here we got 1. Okay, 1, yep. Let's quickly go here and see. So first what we sent, root, we sent 0 by default, and by default sending 0, we know what's the value of that 0th index. In preorder it is 3, and we will start our array, like we will start traversing our array from start 0 till the last. Now we have mid formula. So from the mid formula what we got, 1. So hence our mid became, sorry, here our mid became 1, 1. Okay, and the value which this 1 represent in the in order is, let me just like in order. So mid represent in order, this represent, root represents pre-order. in like they represent themselves in these arrays. Okay. Okay, I wrote that and everything shifted. Yeah, now it's better, correct? So let's just continue ahead. Let me just enter once. Okay. So now you will ask me, Tushar, why we are doing mid is greater than start. Very simple. See, right now my mid is what? My mid is first index. And what is my start index? Which is 0. Suppose in the case my mid is also 0 and my start is also 0. Just tell me whether there will be any element before the mid, then no, there will be no element before the mid because start itself is the mid. That's why we did this. So if my mid is greater than start, that tells us that there are some elements on my left side of the root. So this will tell me there are some elements on my left side of this tree. Hence I need to create a root, like I need to create a left node also for that particular root. Okay. So if my mid is greater than equals to start, so then we have, sorry, I wrote something here. Suppose if my mid is smaller than equal to start, then we have no values in the left subtree. Otherwise, we have some values. So now we should move our root value one step ahead. Okay, let me explain this part now. So we have some values now. How we will know what will be the next root? So from this array, this whole array, suppose suppose here I am writing now. Suppose here it can be 10, 9, 8, 9, and then 3 and then so on. So before 3 I had so many values. How I will know which one is the root from this? In this case, this preorder will help. As I told, preorder will always give us the first value as the root value, even of the subtrees also. So what we will do, we will increase our root, this root pointer we have now, we will increase the value of the root pointer by 1. So now the root pointer was pointing to the 0th index. Now the root pointer will be pointing to the first index, which will be 9. Okay, I hope so you got the point. So here we can see now, see, we have this condition satisfied, mid was greater than start. Hence we need to go on the left side of the tree. In the left side of the tree, when we go, we increase our this root by +1. Correct, we will increase it, so it will become 1. So first it was 0, now it will become 1. First index in my pre-order represents 9, hence my value is 9. Now my start will remain same. I will not change my start because again I have to break it into a left array na. So it should be whole, like it should be whole array, like suppose if it was 10, 8, 9, 3, 3 and so on, then I need everything of the left side in my left subarray, like in my left subtree. Hence my start index will remain 0 only. So start index was 0, but my mid index will change. Why my mid index will change? Because my left subtree will be only till this 3 node, like before this 3 node. After this 3 node, everything was the right subtree. Hence, I should only keep my left subarray before this mid minus 1. Hence, mid minus 1. My mid was what? 1 in my previous iteration, my previous recursion. So now my mid will become 0. And my in order new mid, so see, new mid means, so here 9 is on the first index in the in order, which is 0th index. Hence new mid will become 0. So now we can know that my new mid is equals to the start and my new mid is also equals to the end. And if when this condition arise, we know that there is no left and no right, which means we will not trigger this condition, we will not trigger this condition, we will directly return the answer root. Okay, that's what it will happen when we have both our start and end equals to mid. Okay, this was for the left part, and there is no more thing in the left, hence we closed here. Hence it will return to the 3. Okay, but now go for the right part. So for the right of the 3, we need to follow a function, like a particular, you can say, calculation. I will explain you that also. Let's first quickly wrap this first part. So here I mentioned that move our root one value step ahead in pre-order array, because after root we have left subroot value in the array. So you can know that how we traverse in pre-order, from root we go to the left. Hence we only doing +1. Okay, and here I mentioned what this start and all helps. You can read it by pausing the video. Let's go for this part. Oh, sorry. Let's go for this part. Why I wrote mid should be smaller than end. Just imagine you are on the 7th, which is 4th index, and your mid is also on the this index only. So your mid and end both are same. So tell me, there will be any value after the end? No, there will be no value after the end. Hence, there will be nothing. That's why our mid should always remain smaller than end. Then only we can have some values on the right side of the tree, right sub root. Okay, subtree. Sorry. Okay, let me explain this function very quickly. We know what is preorder, and we know this argument represents our root index in our preorder array. Correct? Why I wrote mid minus start plus 1 and root? That's the great part. So first thing, in inorder array, if you see whatever our mid is, suppose our mid was 1, for current iteration our mid is 1. So if I minus the index of left index, which is 0, because we know, see here, what is our start? 0. Hence, our mid is, sorry, hence here we wrote mid, which represents 1, start, which represents 0. Okay, and we are doing plus 1. What this thing is giving us? Basically, this thing is giving us how many elements we have in the left part. See, so mid minus start will give us how many elements we have in the left part of the in order. So we have one element in the left part of the in order. Why we are doing plus 1? We need to count this also, na? So if we count these two, then only this thing will become our right subarray. So hence we are taking these two. For this 3 we are doing plus 1. Overall what we are having is mid minus start, which is 1 minus 0, plus 1, which is equals to 2. Okay, now how we will use this, now you can know that our right, like for the root for the right subtree will be second index in our pre-order, which is 20. See, 20. Okay, and then one more thing which is more important is, that the next root will be after two values, but of what? It can be like 20 will be the current root, and after two values you will have next right root. So 1, 2. That's why you need to specify this root also. So here what we are doing, our previous roots index plus our current calculation. So what it will give? So previous root index was 0 plus 2. It means next value 20 will be our new root. So now previous root will be 20 plus 2. Then our 7 will be the next right root. See, 7 is the next right root. That's why we are doing root plus. This will give us the next right subtree root from the preorder array. Hence we are calling this function like this. So why we are doing mid plus 1? I hope so you understood, because now we want to traverse after this 3. Not this 3 should not be included. From 15 we should traverse, and end will be the obviously end of the route. Let's just go in our this part. So here you can see our right was 2, which represents 20. Then we did mid plus 1 equals to 2, and end became 4. And mid in order we did like we got the third index, because in order 2 is on the third index. Okay, but you can see that our start is currently smaller than mid, and our mid is smaller than end. Hence, this tells us that we have left and right subtrees of 220 also. So let's just do it. Right subtree 20. This is the right subtree 20. Let's see what will be the left value. Now left, how I told you how we will calculate left. Previous root plus 1 will represent left, so it will become 3. And third is the 15th index here, you can see in pre-order. And start, now start will become what? Start will start from mid minus 1. So this mid, okay, let's wrap it. So start will start from our root, which is our 2. From the, see man, we will start from here, no? Once we reached here, then we will start from here. How I should explain you this, man? See, in our left side function, what we wrote was our start remains same. We don't change any start value. Only in right side function we change the starts value. So here in our first, like in our 20th function, like right side one for the main root, what was the start? It was 2. Hence, in our left part of this 20th function, we will have start as 2 only. Okay, but our end will change, our end will become mid minus 1. So 2, which means, and our in order, if we go and find 15, we know it's on the second index. This tells us that there is no left and right values, because mid is equals to start and mid is equals to end. Hence no left and right values. Similarly, for the right side, if we do, we need to calculate using that formula. We will get the index 4, mid will get plus 1, because we need to traverse for the right side. It will also become 4. End will also become 4, because that's the last index of the array. And min order, if we see, it is also in the last. So here also 4. Everything is 4. Hence there is no left and right. Hence our problem is solved. And overall we will return this tree through root s. Okay. We'll just minimize this. And you can just check the whole function here. Yep. So let's submit our code and see whether it works or not. It works fine. And during interviews you don't have to go this much deep. I went this much deep so that I hope that you can understand the solution. In interview you can just say that my pre-order traversal will give me the root values, like will give me the root sequence, like root, like that it will give me, so I can get root from it. My in-order traversal will tell me how many elements are on the left and right of the root. Okay, so that to keep track of my number of elements on the left and right, I created a map. And simply I just filled the values with their respective index in the map, and I created a split helper function. The split helper function works on two logics. First, it will split my this main in order array in two halves, left and right half, so that we can keep traversing on the left and right sides and keep making tree recursively. Mid will give us the value, sorry, the index from which we have to split the array. Suppose 3, then we have to split the array from the first index, like before every index before first will be the left, and every index after first will be the right subtree. And then I wrote the logic for the mid, for the left subtree and for the right subtree. And finally I return the root. And then you can just show them this dry run. You have to write the dry run, and while doing the dry run you can explain how the value got calculated for the right root, for finding the right root. And that will be the enough, that will be best for the interview. And I hope so you understood the problem. Try to watch the video 2 3 times. I will provide this code also in the description, so that you can go through it. And for me this was not a medium level question, obviously it can be a hard level question. All the best.